Coronaviruses have been around for much longer than you might think. These viruses are not a recent phenomenon, but rather, they have a long and intricate history that dates back nearly a century. Understanding this history is crucial to comprehending the challenges we face today. The story begins in 1931, when a new respiratory disease was reported in chickens in North Dakota, USA. This was a time when the world was still grappling with the aftermath of the Great Depression, and scientific research was making significant strides despite limited resources. By 1933, scientists identified the cause as a virus, later named avian coronavirus. This discovery was a milestone in virology, marking the first time a coronavirus was linked to a disease in animals. The identification process involved meticulous research and the use of primitive yet effective laboratory techniques. In the 1940s and 1950s, researchers discovered coronaviruses in mice and other animals. These viruses, like mouse hepatitis virus, showed how coronaviruses could affect multiple species. This period was marked by a surge in scientific curiosity and the establishment of foundational knowledge about these viruses. The first human coronaviruses were identified in the 1960s. Scientists studying the common cold found two strains, B814 and 229E, which were later classified as coronaviruses due to their crown-like spikes. This discovery was pivotal, as it linked coronaviruses to human diseases for the first time. Fast forward to 2002, when the first major coronavirus outbreak, SARS, emerged in China. It spread to 28 countries, infecting over 8,000 people and causing 774 deaths. The SARS outbreak was a wake-up call for the global health community, highlighting the need for rapid response mechanisms and international cooperation. Then, in 2012, MERS appeared in Saudi Arabia, with a higher fatality rate but lower transmission. MERS, or Middle East Respiratory Syndrome, posed a different set of challenges, emphasizing the diverse nature of coronaviruses and their ability to cause severe illness in humans. In late 2019, a novel coronavirus, SARS-CoV-2, was detected in Wuhan, China. By March 2020, the World Health Organization declared COVID-19 a global pandemic. The virus spread rapidly, causing millions of deaths and unprecedented societal disruptions. The COVID-19 pandemic has been a defining event of the 21st century, reshaping our world in profound ways. The rapid development of vaccines like those by Pfizer and Moderna marked a turning point. By 2021, billions of doses were administered worldwide, saving countless lives. The vaccine rollout was a monumental scientific achievement, demonstrating the power of modern medicine and global collaboration. Today, the virus continues to evolve, with new variants like Omicron and its subvariants dominating. Scientists are still studying its origins and long-term effects, including long COVID. The ongoing research is crucial for developing effective treatments and preventive measures. 5 years after COVID-19 changed the world, we've learned much, but challenges remain. The history of coronaviruses reminds us of the importance of science, cooperation, and resilience in the face of global health crises. Stay informed, stay safe. The journey of coronaviruses from the early 20th century to the present day is a testament to the relentless pursuit of knowledge by scientists and researchers. Each discovery, each breakthrough has built upon the work of those who came before, creating a rich tapestry of scientific progress. The identification of avian coronavirus in the 1930s was just the beginning. As researchers delved deeper into the world of viruses, they uncovered more about the nature of these pathogens. The discovery of coronaviruses in mice and other animals in the mid-20th century expanded our understanding of how these viruses operate across different species. The 1960s brought a significant leap forward with the identification of human coronaviruses. This era marked the beginning of our understanding of how these viruses could impact human health. The strains B, 814 and 229E, were the first to be linked to the common cold, paving the way for future research into more severe coronavirus-related illnesses. The SARS outbreak in 2002 was a stark reminder of the potential for coronaviruses to cause global health emergencies. The rapid spread of the virus and the high mortality rate underscored the need for vigilant monitoring and swift action in the face of emerging infectious diseases. MERS, which emerged a decade later, presented a different set of challenges. With a higher fatality rate but lower transmission compared to SARS, MERS highlighted the diverse nature of coronaviruses and their ability to adapt and evolve. The ongoing research into MERS has provided valuable insights into the behavior of these viruses. The COVID-19 pandemic has been a defining event of our time. The rapid spread of SARS-CoV-2 and the global response to the pandemic have reshaped our world in ways we are still coming to terms with. The development and distribution of vaccines have been a beacon of hope, demonstrating the power of science and international cooperation. As we continue to navigate the challenges posed by COVID-19, it is essential to remember the lessons learned from past coronavirus outbreaks. The history of these viruses is a reminder of the importance of preparedness, research, and global collaboration in addressing public health threats. The story of coronaviruses is far from over. With new variants emerging and ongoing research into long-term effects, the scientific community remains vigilant. The work being done today will shape our response to future outbreaks and help us better understand the complex world of viruses. In conclusion, the history of coronaviruses is a testament to the resilience and ingenuity of the scientific community. From the early discoveries in the 1930s to the rapid development of COVID-19 vaccines, each step has brought us closer to understanding and combating these formidable pathogens. As we move forward, it is crucial to stay informed, support scientific research, and work together to overcome the challenges that lie ahead. Stay informed, stay safe,